Good morning, everyone. I hope you are having a good Wednesday. It's the middle of the week, and it's time for our third thermochemistry lesson. So at the end of our last video, we were talking about the specific heat capacity and what that really means. And today we're going to talk about how it's used in calculations. And so remember, the specific heat capacity is symbolized or abbreviated as a capital letter C, and it is the amount of heat it takes to increase the temperature of 1 gram of the substance by 1 degree Celsius. And often it's simply called specific heat. We kind of take out the word capacity. And water has a huge value when compared to other substances. The specific heat of water, represented by C with a subscript H2O, which means that it's the specific heat of water, is 4.184 joules per grams degrees Celsius. So this means that in order to change the temperature of 1 gram of water by 1 degree, so just taking it from 0 degrees Celsius to 1 degree Celsius, or 50 degrees Celsius to 51 degrees Celsius, it requires 4.184 joules. Now, metals, for example, have a like the specific heat of aluminum is about 0.9 joules per grams degrees Celsius. So you can see there's a big difference in their numbers. And so this is why it's going to take a long time to heat up and a long time to cool down water. This is why it takes a while for your pool to get warm when it's, even though the air outside is starting to get warm. It's also why once the water is hot, it takes a while for it to be able to cool down. And the energy required to change the temperature for, for example, a whole swimming pool of water can be calculated using the following formula. Q equals mcDeltaT. And with this formula, Q is equal to heat. That's our symbol. I know you're like, why is heat not like an H? But that's because before this formula was created, H was already taken in a different formula. And so it's Q for some reason. And remember, heat is measured in joules, and M is mass, the way we've always had it be. And its mass unit is grams. And we know that delta T means change in temperature. So the triangle is the Greek letter delta, which is like the Greek letter D, I guess is kind of how they used it. And the delta, anytime you see this triangle in a math problem, it means the change in or subtraction. And so the change in temperature would be our final temperature, so T final minus our initial temperature. And then C in the formula is, of course, our specific heat, and it has units of joules per grams degrees Celsius. Now, I forgot to put that our change in temperature is measured in degrees Celsius as our unit. And so we're going to do 2 examples in this video. We're not going to do too many, but I'm going to give you a PDF of practice problems. You don't have to do them, but I'm going to give you practice problems with the answers so that if you want to do some practice, you can. So for the first one, what you're going to do is you're going to read through it, and I kind of highlight or circle or underline the numbers as we read. So it says it takes 487.5 joules of energy to heat 25 grams of copper from 25 degrees Celsius to 75 degrees Celsius. And then the question says, what is the specific heat of copper? Now, we're going to do the guess method the same way we did with density. And most word problems, you're going to list out kind of like what numbers are given to you in the problem as are given. So we know that because we have 487.5 joules, joules is energy. So that means we know Q is 487.5 joules. And then we have 25 grams, which means that's our mass. So mass is 25.0 grams. And then we have two temperatures. And then because it says from this to that, we know that the 25 degrees Celsius is going to be our initial temperature, which we're going to write as T with a subscript I. That tells us it's our initial temperature is 25 degrees Celsius, and that means our final temperature, which is a T with a subscript F, is going to be 75 degrees Celsius. And then what's important is we see the question word, what is? It says, what is the specific heat of copper? And so that tells us that we know that the specific heat, which has an abbreviation of C, and we're going to put copper's symbol, Cu, as an abbreviation or as a subscript for this, is our question mark. That is our unknown. And so remember, in the guess method, guess is an acronym. The G stands for given, so we wrote down everything given to us in our problem. The U stands for unknown, so what are you looking for or trying to find? In this case, that would be our specific heat. And the next letter, E, stands for equation. So we write down our equation. And so we know that our equation is Q equals mc delta T. And we also know there's a formula for delta T. It's T final minus T initial. And so once we have our formula, the first S stands for substitute, which means to plug in your numbers. So substitute the letters in the formula for our numbers. And so the first one we're going to look at is because the Q equals mc delta T formula has delta T in it, we're going to go ahead and calculate that one first. So we know that delta T is T final minus T initial, which means it is 75 degrees Celsius minus 25 degrees Celsius, which means delta T is equal to 50 degrees Celsius. And then we can plug all of those into our Q equals mc delta T, which, by the way, some people call this the mcAt formula because the delta looks kind of like an A, so it looks like it says Q equals mcAt. But that's just kind of nerd humor. So we know that the Q can be substituted for the number 487.5 joules, and it's equal to our mass, which I'm going to put our mass in parentheses just because it helps keep our units and our numbers kind of together. We don't know our specific heat, so I'm just going to keep C of copper there. And then we know that our delta T is 50 degrees Celsius. Now, all of these numbers on the right side of the equal sign are being multiplied by each other. And so it's 25 times C times 50. And the first step you're really going to need to take if we're trying to solve for our specific heat of copper, because remember, this is what we're trying to solve for, is you want to simplify. So on the left side of the equation, there's nothing to simplify. All we have is one number, so I'm going to keep it the same. But on the right side, we can simplify it by multiplying 25 times 50. And if you do that, you get 1,250. Now, that means you also multiply your units. So that means you have grams and degrees Celsius still there, and it's still being multiplied by our specific heat of copper. Now again, if we're trying to solve for copper, the specific heat of copper, we want it to be by itself in the formula. And so that means we do the opposite of the math. If it's being multiplied by 1,250, that means we're going to divide by 1,250 grams degrees Celsius. And so we do that on both sides. And so on the right side, it's going to cancel out. And we're going to get our specific heat of copper is the only thing that did not cancel out on the right side. And on the left side, when we divide, we get 0.39. And if we look at our units, none of them cancel out. And so that means we have all three of them still there, written exactly the way it is. And that's our answer. And we can see that our units, joules per grams degrees Celsius here, line up with how they're supposed to be. Like that's what the units for the specific heat are supposed to be. So that's an indicator that we did our math correctly, which is a good sign. And so, yeah, so that's kind of how you do this problem. So just some basic algebra. Hopefully it's not too complicated for you. And then if we look at example number 2, we're going to solve it exactly the same way. And in fact, if you want to, you can pause the video and try to solve it on your own and then watch as I solve it after you press play. So go ahead and press pause, try it on your own. Okay, so hopefully you've tried it on your own, and let's go ahead and look at it. So it says how many joules of heat, so we see that question word, how many joules of heat, so that's what we're looking for, are needed to raise the temperature of 10 grams of aluminum from 22 degrees Celsius to 55 degrees Celsius if the specific heat of aluminum is 0.90 joules per grams degrees Celsius. So let's go ahead and again follow the guess method. So G stands for given. So let's write down everything we're given, and I'm going to do it in order. So the first thing that we highlighted in yellow is 10 grams. So grams tells us that that's our mass. So we have 10.0 grams of aluminum. And we know that our initial temperature, because again it says it's from this to that, so we're starting at 22 degrees Celsius, and our final temperature is going to be 55 degrees Celsius. And it says that the specific heat of aluminum, so C of aluminum is equal to 0.90 joules per grams degrees Celsius. So we've written down everything that they've given us, and then so that's our G for given, and then U is unknown. So what is unknown? Well, they want to know the joules of heat, which means Q is our question mark, what we're looking to solve. So we have given, unknown, the next step is equation. So our equation is Q equals mcΔT, and that delta T is equal to T final minus T initial. So we can go ahead and solve for our delta T because we have both of our temperatures. So that would be 55 degrees Celsius minus 22 degrees Celsius means that our change in temperature is going to be equal to 33 degrees Celsius. And so if we plug this in, we don't know what Q is, so we're going to leave that alone, which is kind of nice that we're solving for that because it means we don't have to rearrange our equation. Q is already by itself. And so then we have a mass of 10.0 grams times a specific heat of 0.90 joules per grams degrees Celsius, and our change in temperature is 33 degrees Celsius. And if you look, we can kind of see some units that are going to cancel out. Our specific heat has a divide symbol in the middle of its units. That means the grams and the degrees Celsius are in the bottom of the denominator. So grams are going to cancel out, and so are degrees Celsius. which means when we solve and multiply, Q is going to be equal to, the only unit that's not canceled out is joules, which is good because we know that Q, or heat, is measured in joules, so we know we've set up our problem correctly, and all we're going to need to do is multiply 10 times 0.90 times 33, and when we do that, you're going to get 297 joules of energy. And so that is really great. And so what you can do is check out the PDF for practice problems. Remember that they will have the answers, but not how to work out the problems. So you're going to have to do them on your own, and I highly recommend doing them just so that you can get some good practice and you can be really great at it for quizzes and tests. And because you know that you're using notes, having those worked out will be really helpful when it comes to those. So good luck.